Thank you, sir. A very good evening to everyone. Myself, Dr. Surekha Vishnupan Munde. I'm co-coordinator of this FDP. I heartily welcome today's resource person, Dr. Manish Hatwar, Head Technology Innovation Offshore Wind Business, Siemens Gamesa, Germany. He is going to deliver his lecture on the topic renewable energy, an important need of today's offshore wind enabling global energy decarbonization. I also welcome all the enthusiastic participants who have been joined for this session. Yesterday we began our journey with inspiring sessions, and today we continue on the path of knowledge. As Benjamin Franklin said, an investment in knowledge pays the best interest. I promise day two to be equally enriching. So let us begin the day with engaging session. Sir, I request Dr. Kakade sir, please introduce today's resource person.
ये बेड होगा तू आ बता जाइए एक बेड एक्स्ट्रा पर है तू आ बता जाइए
Good evening to all participants. Good evening to all participants on second day of this AICT training and learning sponsored online FDP on strategic implication of energy efficiency, conservation and sustainability for global competitiveness. Organized by IQSSL in association with Department of Civil Engineering of PS College of Engineering, Chhatrapati Sambhajinagar, Maharashtra. Today on third session, we have with us Mr. Manish Hatwar sir. It is my privilege to welcome a leader whose career represents the perfect blend of industry expertise and academic collaboration. Mr. Manish Hatwar sir is a senior executive in the renewable energy sector, currently leading offshore technology power plant platform at Siemens Gamesa Renewable Energy in the Germany. Mr. Hatwar sir is a rare blend of strategist, technologist, and educator. With a strong foundation in engineering, he has emerged as a thought leader in digital transformation, data analytics, and intelligent system, leading multidisciplinary teams to deliver complex initiatives with tangible impact. He bridges the worlds of industry and academia. Mr. Hatwar sir was collaborated with universities, mentored students, and contributed to the research, all while executing high-stake industrial projects. This dual perspective allows him to apply cutting-edge research to real-world challenges and bring practical insights back to the academic sphere. A champion of innovation, he has leveraged AI, machine learning, and digital platform to drive operational efficiency and strategical growth. His ability to align diverse stakeholders and translate complex ideas into actionable results set him apart. Today, he will share his insights on renewable energy and important need of today's era and offshore wind enabling global energy decarbonization. Now, I hand over the session to the speaker, Mr. Manish Hatwar sir. Hatwar sir, please unmute your mic.
Okay. You hear me now?
Yes.
Thank you very much for giving me an opportunity to have the interaction in such a big forum, and it would be educational for me also when I will interact with such a different kind of brains, and I will have also the insights about how the industry is doing that. So it's not one-sided. We will have some 15-20 minutes at least spare for the question and answer in the end of the session. Let me try to share on my screen. You see my screen and the only presentation, or you see something more or different?
Sir, it's okay.
So you see only presentation?
Yes, yes.
Yeah.
Okay, let's start. So what we are going to talk about today is how the offshore wind industry is enabling the decarbonization of the energy sector. So I'm not sure whether how many of you are already aware of the number called 427 ppm, parts per million. It's a carbon concentration in our atmosphere, which has already witnessed highest global CO2 levels in May 2024 globally. So it's a new record now that 427 ppm CO2 levels has been reached globally. So that's our starting point to understand what are we facing. And we all know that we want to limit our global warming by 1.5 degrees Celsius. And that is because of the greenhouse gas emissions. To reach to that, we need to have this peak of emission within this year, 2025. If we don't achieve that, we will have a drastic scenarios. And it has to decline by 43% by 2030 if you want to keep our global average to 1.5 degrees Celsius. So that's one of the important parameter just to look for. And there are a lot of urgent and important actions to be needed in future to stay in this 1.5 degrees Celsius scenario. As I said, in 2024, we have already seen a record-breaking climate events. The yearly average temperature has gone more than 1.6 degrees. So our target was 1.5. We are already seeing the average 1.6. Last 10 years, average temperature exceeded 1.3. So we are already going beyond pre-industrialization levels. The very first time we have seen in 2024. If you see the chart on the right side, stay with me, I will explain you that what does it reflects. On the x-axis, you find the years by 2050, and on the y-axis, it shows the gigaton of CO2 emission. So if you want to stay within 1.5 degrees Celsius scenario, we have a budget of around 600 gigaton of the CO2 emission. That's the carbon budget, which we can consume or emit. If you exceed that 600 gigawatt scenario, and if you say assume that 800 gigawatt, then we will be at average 2 degrees Celsius peak. And if you follow the line, there are 3 lines here, green, blue, and red. Currently, we are at the red line, which shows that by 2025, if we reach to the peak, if you want to stay within the 1.5 degrees Celsius scenario, then all the emissions has to become zero by around 2030, 35, which is drastically within next 10 years. I think we are not there. So it means this graph shows that we missed the bus globally to contend to 1.5 degree scenario. What does it mean? It would be like we need to do a lot of different actions as a world to retain our greenhouse gas emissions lower so that we don't exceed 1.5 degree scenario. I am very pessimistic. I don't think that we can restrict ourselves to 1.5 degree scenario. We will reach and we will cross 2.2 degree scenario. And that means there are many studies done what it means, but let's see. So the highest greenhouse gas emissions are contributed, and you might see here that the CO2 is already 1.5 times the pre-industrialization level. The methane gases are 2.7x and nitrox is at 1.3x compared to the pre-industrialization. Please interrupt me if you find there is a breakage in my voice or a network. Otherwise, I will keep on talking and I will not understand whether you follow me or not. Okay, so out of that, all the total emission, 70 to 75% of the greenhouse emission is coming from energy sector. What does this energy sector means? This energy sector is fully fueled by fossil fuel. and which is, if you say this energy sector combines of electricity, heat, transportation, and some other sectors. However, that all emissions coming into the energy sector, the electricity sector itself contributing to 40% of emission. So if somehow we find a smarter solutions which decarbonizes electrical sector, then we will hit at least 40% of the emission problem. And that's why today we will focus more on to the electricity sector, because I and my organization contributes towards it. So what are we doing? There are some good improvement happening, even though the picture in the beginning I shown that we will not contain ourselves to beyond 1.5 degrees Celsius, we will reach to 2 degrees Celsius scenario. However, there are many good things are also happening. The electricity sector specifically has already seen the highest peak in 23. What does it mean? It means now we are in a positive direction to reduce the emissions which are happening from the electricity sector globally. So you will see on the chart on the right side, the fossil fuel driven electricity mix, which is contributing 60% of fossil fuel, is contributing 96% of emissions. So if somehow we try to address coal, natural gas, and oil driven electricity sector, we will be addressing 98% of electricity sector's emission. So I think that narrow downs the whole bigger funnel to a smaller area where we say, okay, how do we eliminate coal, natural gas, and oil driven energy electricity production? We have seen that the 2% decline in the emission in 2024 last year, meaning it's a declination already happening. And the current forecast shows that the world's 50% of renewable energy, we will be reaching global consumption renewable energy by 2026, that's next year. We have seen that the 40% additional electricity coming from the renewable sector globally in 2023 itself. So we discussed about the emission coming from energy sector. Within energy sector, the electricity sector is major contributor. And within the electricity sector, we say, okay, what should we do? So the global offshore and onshore wind is one of the renewable source of energy which can contribute into reducing the emission problem. We have so far globally installed 1 terawatt worth of assets to generate the electricity. And our target is, the global target is 2.5 terawatt, meaning it will be 1.5 times or 2 times growing further by 2033, which is like close to less than 8 years. We want to double the target and reach to that target. What does it mean? In 2023 itself, we have seen record-breaking installation, 120 gigawatt, which was 40% higher than the previous year. And you would be surprised that out of 120 gigawatt installed globally in 2023, 75 gigawatt was coming from China itself. So China alone is installing close to 60 to 80% of global installation, one country. And if you want to just follow that chart on the right side, in next 8 years, 1.5 terawatt installation, meaning every year the industry will see a growth by 10% year on year. That is the CAGR, or compounded annual growth rate. And which are the markets which are driving globally this the installation? There will be China, US, Germany, India, UK. They will be close to adding 70% of the capacity in next 10 years. Yeah. So we are in India, I am in Germany. So I think we are in the top 5 countries which will be adding to this renewable energy, which will be part of this journey of reducing the carbon emission. So I think we should be proud of that. So currently the offshore wind industry at only 7% in 1 terawatt installed. So as I said, globally, currently the wind installation is 1 terawatt, and out of that, only 7%, roughly 70 gigawatt, is installed from the offshore wind. It means the offshore wind can grow very high and it has a lot of demand. So this chart was offshore and onshore combined. Let's look into the offshore situation. So offshore wind is estimated to grow 6 times in the next 10 years. So that's the huge potential to evolve the offshore wind industry and contributing to the net zero or carbon reduction. So currently the offshore wind industry is, just I said, 7% of the total installation, that is 74 gigawatt roughly. And offshore industry is having a target to add 400 gigawatts till 2033. What does that mean? It means every year offshore wind installation has to increase by roughly 20%. Yeah. And we have already seen that in 2023, there was a record installation in offshore, that's 11 gigawatts. So out of 74 gigawatt, 11 gigawatt was installed in 23 itself, which was 23% compared to the previous year, 32%, sorry. So that's the year-on-year growth in 1 year. However, the 32% growth which we seen in 23 would not last forever. So it's like on an average, it would be around 20%. And which are the markets, those who are going to drive this? It's Asia Pacific, Europe, and US. And Asia Pacific will lead this installation race by 230 gigawatt. Why? Because as I said, China is driving it very, very high. And we will see that which are the parameters and factors because of which China is able to install such a high volumes of wind power compared to the rest of the world. So the targets are ambitious. Let's see how the countries are meeting these targets or not. So we all know that so far we understand that the wind power and especially offshore wind has an increasing importance into the net zero or carbon reduction journey. So why that offshore wind power is having so much of importance? Because you know that when the wind powers in the sea, there are very high and stronger wind resources with which you can have more wind energy produced compared to on the ground. And then in the wind industry, for the offshore wind turbines, there are no size limits. So you can have fewer constraints. Like in onshore world, there are not many constraints. Like there are distance between the turbines, distance between the house and roads. They are the constraint. Whereas in offshore world, there are no constraints like that. So that's why you can go larger and larger with the turbines. Whereas also another is in onshore world, you have land availability restriction because of the population density, distance between the house and roads, that what I said. So all these three major criteria are in favor of the offshore wind industry, and that's why it is increasingly having more importance. So we discussed that China is contributing a huge, and it is developing a lot and adding a lot of renewable wind power. Why? Let's try to understand that, why it is a powerhouse. So it has achieved 50% of existing installation capacity and 65% of new capacity installation since the first project, which was done in 2010. So China is driving it. Why? The first advantageous point for China is supply chain advantage. So all the wind turbine manufacturer, close to 60% of the components are coming from China, even though the installation happening in Europe or USA. So the suppliers are in China. So they have very strong manufacturing base. They have very good natural resources like a rare earth material. And we know all that discussion about the batteries and also the magnets, which needs a rare earth resources. And they have components which are at low cost because their technology with respect to manufacturing and the labor cost is very economical. And they have done this at the economy of scale, meaning they have industrialized their production. The more you have the industrialized production, you will have a more volume benefit. More volume meaning more reduction in your base cost or fixed cost, meaning you are more competitive in component supplies and cost. So that is a supply chain advantage. But then what else? They also have a strong political support. So they have streamlined their permitting because there are central and local governments. They need to provide the permits for such a programs or such a projects, big projects like onshore and offshore to install. There is a huge permitting requirements. Thousands of paper and multiple agencies approvals are needed. That the government has a little bit more streamlined, and their infrastructures are supported because the state-owned companies they are driving the grid connection and transmissions and port infrastructure. Port infrastructure is really important for the offshore wind industry because if you don't have the right quality of port, you will not have the better and bigger machine installed. There are constraints. And then finally the monetary support. For example, you might hear that China is supporting a lot of subsidies to their R&D and local initiatives to develop the wind industry. So that helps them to again install more wind power. And then the third dimension is emerging trend. What they are doing is they are growing their competitive auction systems to reduce the pressure onto the price. They have good technological advantage. What they have done is they have invested so much into the R&D that if you hear the bigger machines, they are going up to 300 rotor diameter, 20 to 25 megawatt rotor size, each turbine, which is huge. And they are more driving now AI and intelligent technology integration race also. So all these parameters gives them an edge to go globally and install more into the offshore wind power. However, Europe is also doing something good, and they are also trying to grow despite of many challenges. And within Europe, Netherlands, UK, France, Denmark, and Germany, they are on the lead. And Europe is the second largest market for technology as a technology leader because all the technological innovation happening into the wind turbine area is especially happening in the European side. So although there are short-term some slowdowns in the European market, we will see that in details because of the economical challenges. However, the installation capacity until 2030, we are still targeting to have by around 110 and 120 gigawatts. So that is also a big one, but not good enough. So what are the challenges Europe is facing that we need to see? So I think it is just opposite to what we have seen into the China. They are having the advantages, and here in Europe, there are some challenges on the same way. The permitting cycle here is very sluggish. I'm not sure how many of you know that if you want to have a permit to install a wind power project, it takes 6 years to 8 years to get that permit. For the offshore world. For onshore world, it is average 4 to 5 years. So that's very long. By that time, your all business case and economics of the project goes off. The grid bottleneck. I'm not sure how much you are aware from the northern countries of the from the Europe to the southern countries. If you want to transmit the power, wind power, there are many bottlenecks into the grid. Most of the time, what happens is you have enough wind in the northern part of the Germany, say, and then you have so much of energy production there, no demand, they have to curtail or shut down the wind power because they cannot transmit the same energy to the southern states or southern part of the Germany. And unfortunately, the demand of a southern part of the Germany is satisfied by importing energy from the neighboring countries. So even though Germany is having a surplus energy in the northern state, they cannot transmit it to their southern states to cope up. And there are a lot of economic pressure like rising inflation, interest rate, and supply chain issues and infrastructures like a port and the installation vessel capacity. So there are a lot of challenges in Europe, like these big machines, if you want to install them, you need a lot of big installation vessels. I'm not sure how much you are aware about the installation vessels. They are very big ships with giant legs in it, and then the ship, when you want to install a turbine into the sea, the ship actually puts down their four legs onto the ground, and then the ship goes above the water level. It's interesting. If you get a chance, have a look onto the YouTube videos how the offshore machines getting installed. But there are also trends and opportunity because Europe is also a market leader into some of the technology development. So the floating turbines or floating turbines, meaning the turbines where they can float in the water because of the water depth is too high, the ground is too deep. You cannot have the monopiles going in most of the time more than 60-meter depth. Then you prefer to go for the floating, and that Europe is doing really good. Then there is also hybrid wind farms where we say, okay, let's integrate the onshore, offshore, hydrogen production, solar and battery so that we can do some energy storage also. There are a lot of good things happening into the supply chain investment. New manufacturing facilities and components are getting manufactured in Europe, and there is also a law regulation called Net Zero Industry Act that is promoting to be more carbon neutral to get the supply chain and the products or components manufactured in the Europe rather than more depending on to the Chinese suppliers. So these are the more challenges and trends, opportunities which Europe is facing. I think I would also like to touch upon some Asia Pacific, excluding China, which is also considered as the emerging market for the wind turbines and wind energy. So close to 2.5 terawatt of the energy is untapped, which is not still captured in the Asia Pacific region. And the target there is to have 160 gigawatt installed by 2040. So this is also a big target. And you will see which are the countries they are leading. The Taiwan is a huge growth enabler. They have huge targets in 2030, 2040. Australia is also driving it. India tried good for the offshore. Onshore is super good happening in India. Philippines, South Korea, and Japan, they are all also trying to transit onto the offshore wind installation. But they have exactly similar challenges, supply chain limitation, because we have a lot of dependency onto our Chinese component suppliers, financial challenges. These emerging markets are very high in the capital cost. You might be knowing that, like in India, if you want to have the loan or personal loan or private loan or credit financing of project, it's 8 to 10% or 7% sometimes. Whereas into the developed countries, this project financing comes with the 4 to 5% capital cost. Similarly, in Asia Pacific, like in Japan, like Vietnam or Korea or Philippines, they are also very high capital cost markets. So that's another hurdle which is not allowing us to ramp up the way we want to have, and regulatory barriers because the policies in that area, in these countries, emerging markets, are not clear. The auction mechanism for energy auction is not yet streamlined. It needs a lot of framework creation. They are trying to copy and paste some of the European auction mechanism, but that is also not 100% applicable to their market. So these are the challenges, but there are also opportunities. Like for example, the governments are more committed in this emerging markets. So they are driving ambitious target all across countries, and there are a lot of improved regulation and incentives for the local R&Ds and component supplies. So I think with that governmental support, there will be more potential to have more installation in future. And there can be a joint R&D happening between, say, European OEMs and the Southeast Asian countries, so that they can also ramp up their technology. So I am still optimistic about the Asia Pacific zone, which will be ramping up for their renewable installations. But looking at the US, I think that's the critical one. I think you might have seen lot many news and lot many articles about how the US is doing or US policy is doing. They have their own challenges because technically, if you see, they have 4 terawatt of technical capacity available. How much they installed? Only 0.17 gigawatt today. They have huge capacity, but they are not able to install. They are on track to install 1.7 gigawatt by 2025 and maybe a 4 gigawatt in 26. However, you might know that the current US political shift on the offshore wind, they are not so much of in support of offshore or onshore wind, and that's why they are stopping the permits and already ongoing projects, which is going to derail the offshore and onshore wind industry into US market. So we need to watch for it how US politics and their administration is going to formulate and sail through this turmoil. But we and many experts forecast that the 15 gigawatts worth of the new capacity will be installed by 2030. That is also a good indication. There is also new potential markets like Brazil, South Africa. They are already good into heavily installing the onshore supply chain or onshore turbines. Morocco, Saudi Arabia. We have seen some of the projects happening in Egypt also. So there are not many new emerging markets coming in. So that can help us to achieve our global emission targets. But let's jump into what are the different technologies, innovations are happening in this area. Are we seeing something different and drastically which is going to give us a extra benefit to reach to our scalability and to reach to our to the demand of the new targets? You will see the floating turbine. They are also under lot of R&D investment because they are not fully commercialized technology. So there is a lot of investment happening. Then there is another area which is called hybrid power plant. So integrating wind, solar, and green hydrogen to optimize the energy cost, energy system. So that area is also in the trend, which is not yet fully matured. Then there is a lot of things happening on to simplifying manufacturing logistics by standardizing and modularizing the components. The more you standardize and modularize the component, the more that will help you to industrialize your manufacturing system, meaning you can reduce the cost of the components and cost of the turbine and making the project more viable from the economic perspective. There is also a good push happening onto sustainability. We will touch on 1 or 2 examples in sustainability, what we from the Siemens doing onto the sustainability areas like recycling, reducing, and reusing so that we have the CO2 reduced components. Also, you might have here AI. AI is everywhere, and here also it is. So in AI area, what we are working on is how the energy is optimized, how the manufacturing process is optimized, and how we can automate the few things. So that's the AI powered innovation. Then cybersecurity. Cybersecurity is very critical because we always think about cybersecurity from the IT perspective. IT meaning our laptops, our mobile phones, our infrastructures. However, OT, operational technology, like for example, any power plant, which is gas or steam driven or wind power driven, they are critical infrastructure in Europe because if the 1 gigawatt worth of wind power gets attacked, a cybersecurity attack, and it gets shut down, then it will have a major effect onto a blackout in the countries, which may create a lot of challenges. So that's why cybersecurity is more important, and then grid stability and grid integration to avoid the cyber attacks. They are more into a technology trend nowadays. The more you go into details, you will find also there are more technological evolution happening, like how do we do the autonomous maintenance of the turbines, because the wind turbines which are installed in offshore wind, they are 50 to 60 kilometer away from the shore in the waters. It is not easy to pick up the car and go to the wind turbine to change some bolts or screws or repair some machines. So nowadays we are trying to see the technologies which we can help with the help of drones, robots or automation, so that instead of people going there, can we do something by these drones or robots and do the maintenance quicker and faster with the less cost. So that's another technology area where the offshore wind industry is working on. The next one is advanced monitoring. So how can we monitor our wind farms remotely, intelligently with our imaging and sensing technologies real time, so that we can take the advanced decisions while operating the turbine itself. So advanced monitoring system is important. And then the last one is also predictive maintenance. Like sometimes before any maintenance needed or any failure happens, if we can predict that, then you can avoid the cost of failure and avoid the shutdown or downtime. You can still produce more energy if you can avoid your unplanned downtime. So these are the areas where a lot of technology trends happening in the offshore world. I want to bring it back again, our large targets globally, what we want to achieve versus the demand and supply challenges. So actually, if you want to stay with 1.5 degrees Celsius targets, we are actually racing against the time. We have ambitious targets, which are very challenging, but the current targets, they are not enough, because if you want to reach the targets, it's very difficult. I think I will give you the perspective here, this chart. The blue color shows here that this much amount, so 300 gigawatt of installation is forecasted that we can have by 2030 globally. But the target is 380 80 gigawatt. So that's the target yellow bar. What we can install, what we are in progress, that's 300. The target is to reach to 80 gigawatt. Whereas if you want to stay in 1.5 degree scenario, the installation should be 490 gigawatt. So the 300 is what we forecast. 380 is what we have as target for ourselves. And if you want to reach to a 1.5 degrees Celsius, then it is 490 gigawatt. So it shows that how far we are. Current forecast, usually the forecast is never get realized in reality. So even I think installation by 2030, we are forecasting 300 gigawatt. It would be even lower than that. And you see now 300 itself is 190 gigawatt lower than the 1.5 degree scenario, which is the green bar here. So we are way behind the 1.5 scenario. That's why I was in the beginning saying, I am a pessimistic. I don't see that we will be able to contain our 1.5 degree scenario globally. Okay, how do we look the whole, the left side was the global offshore installation capacity forecast and the right side is more European. And you see the same picture here. The green bar is the 1.5 degree scenario, 196 gigawatt we want to install or we should be installing. However, we will not be able to install more than 110 gigawatt in Europe. So there also we are lagging. So we are running out of the time. So European Union is falling behind the schedule. We say in 2024, only 1.4 gigawatt was installed in offshore world. So we need to do more. So this chart is very interesting. So if you read from the left, the 19 gigawatt, that's 2023 EU installed capacity. So far in total, how much we have installed it by 2023 is the 19 gigawatt. In 24, we installed only 1 gigawatt. So now this total becomes 20 gigawatt. But we have the plan to okay, we have a plan to go to 90 gigawatt, new additional capacity in next 5 years. What does that mean is each year 15 gigawatt installation is needed. and then we will still not be reaching to our target of 111 gigawatt. So that's why I think this industry can grow, but it has a lot of challenge. So European Union's goals are not unrealistic. They are realistic because 19 gigawatt every year, 15 gigawatt installation is possible. However, it is likely that this milestone will be achieved later than 2030. So in 2030, we want to have 110, 111 gigawatt installed. I don't see it is going to happen by 2030. It may be a little 2 or 3 years delayed. Okay, how can European accelerate the offshore wind deployment?
కాదే స్టూడెంట్ గారు నువ్వు రేపు కియా బర్త్డే కదా కేక్
So European can do better onto the permitting. They can speed up their permitting. As I said, streamlining the permitting, because I told you 10 years and 5 years is the average. This slide shows 12 to 5 years of average getting a permit to install a wind turbine project. Grid infrastructure, I gave you an example. The grid infrastructure needs a lot of investments. And then the supply chain, because we are a lot of dependent onto the Chinese supply. And then the last one is the financing, because there is not so much of financing happening onto this project. So a lot of projects, those who did the auctions, they are returning them. Yeah, how I'm doing on the time. Okay, 15 more minutes. Okay, so what Siemens Energy, my wind business, is doing towards sustainability and net zero. I want to bring in 2 examples here, but very high level. We are targeting to have 10 grams of equivalent CO2 per kilowatt hour life cycle assessment. So that is what the offshore wind farms are at, 10 grams CO2 equivalent of the per kilowatt. I'll give you that how much this 10 gram compared to the coal power plant. And let's be patient for the next slides. But then what we are targeting is the 10 gram is not good enough for us. We want to reduce it by further 50%. And what are we doing is to reduce these different emissions. One of the technology here is the recyclable blade. So we are pioneer in the blade solution. You might have seen this picture. The picture is not so appreciable, but they are all long blade wind turbine blades getting dumped into the ground, which is not good. 800,000 tons of turbine blades are getting dumped into the ground as a landfill. But here we wanted to have a solution. This is the challenge. So what we did is we found a solution that we have developed a recyclable bed where we have some special resin which can be dissolved, heated in a mild solution, so that we can reuse and reclaim the glass fiber and carbon fiber out of the blade for the second supply, second use, second life. And then that solution will result into less cost and less harm to the environment and less CO2 emission. And ultimately, while we do that solution, the blade design is exactly same, so no problem into the design. And also the performance and quality of the blade, because if you use the different resin, you should have a stronger blade, and that performance and quality of the blade is not compromised with the recyclability. It's exactly same strength and performance. And then we are not talking about this technology on paper. This is already available, and we already started selling this recyclable blade from 2021. So we have already installed some of the blades and manufactured some of the blades. Another example is the greener tower. Greener tower is not the tower which is in green color, but the tower where how the steel used to manufacture the tower is coming from the carbon-free emission industry. So tower consists approximately 1/3 or 70 to 85% of the steel mass of the turbine. And if we get the steel from the steel industry, which is using the scrap steel as an input material, or those who are using the electrical arc furnaces or the steel manufacturer, those who are reducing the steel out of hydrogen instead of carbon, so instead of carbon emission, that still qualifies as a greener steel. And if we use this greener steel to the production of our towers, what we have seen is this greener steel is qualifies when your emission is less than 0.7 ton of CO2 per steel manufacturing. Currently, the steel which we manufacture, that they are emitting 2 to 2.5 tons of CO2 per ton, and the greener steel which we are ordering from our supplier generates only 0.7 ton CO2. So it has been reduced 3 to 300 times. So this is one of the example. The second example, I have many examples on how Siemens Energy is trying to contribute to the greener targets, not only by producing the renewable energy machines, but also making that machine itself more and more carbon neutral. So just to give you some comparison, if you have a coal power plant, in the life cycle of coal power plant, it emits 120 grams of CO2 per kilowatt hour. That's the coal power plant. And then if you go to the solar power plant, the 820 becomes 48 grams per CO2 per kilowatt hours. We are talking about common unit here. So 800 to 50, that is the high number. But then when you go to the offshore wind turbine, that's the last one. We have 10 grams per CO2 equivalent kilowatt hours. So if we replace the carbon, if you remember my first slide, which I said the coal is the major contributor in our energy sector. So that is how it looks like, 800 from 10. That's the comparison. And this 10, I've shown you on my previous slide, this 10 also we want to make it to reduce by 50%. So our targets are to go to 5 and then finally go to 0. And that would be the ultimate goal. So that's all from my side today. I have next 10 minutes if you have any more questions.
Yes, participants, if you are having any questions, please ask.
No questions meaning you understood everything or you haven't understood anything. I don't know which one is the right one.
Any question from participants?
I'm happy to see somebody typed in saying I understood everything. So that's super amazing. No questions is an easy life for me. I'm not sure whether the session was useful, if it is too easy for you or you were aware of this all data and numbers and facts.
Actually, we people not at all. Organizing committee is talking with you. This is new for us and we learned very much from your slides.
Thank you very much.
Yeah. And it is actually and exactly very useful for research work, R&D.
सर
Yes, please.
सर इंडिया में अगर हम लोग विंड टर्बाइन की अगर बात करते हैं तो सर बहुत सारी चीजों में इशू है। जैसे देखो, जैसे साइट एंड लैंड इशू है, क्योंकि ना तो एग्रीकल्चर मतलब जो फार्मर्स है वो अपनी साइट देना चाहते हैं, ना कोई फॉरेस्ट की लैंड जो है वो लोग देना चाहते हैं। तो ये बहुत बड़ा कॉन्फ्लिक्ट है। उसके बाद भी अगर देखेंगे तो ये जो टैरिफ रेट्स जो है वो लोग गवर्नमेंट हमेशा अपनी पॉलिसी जो है वो चेंज करते जा रही है। तो ये चलते ना, मतलब मुझे ऐसा लगता है कि कहीं ना कहीं हमको विंड टर्बाइन इंस्टॉलेशन में इंडिया को स्पेशली थोड़ा बहुत टाइम लग रहा है इन सब चीजों में। तो इस चीज पे आपका मतलब क्या व्यू है?
I think you rightly touched onto the topics or challenges. You might have seen my one of the slide. I said in many places permitting constraints, they are all connected to the land requirement, the environmental clearances. But then you already touched upon onto the governmental support onto the policies, because we need to have stable policies. Like we see now in US, suddenly this Trump administration came in and they stopped all the projects. So if the government from the previous administration to the next administration keep on changing their policies, then the project's uncertainty increases and their IRR and NPVs goes for the toss. So you raised very valid points. The question is, do we have a solution for it? I think we need to navigate through these challenges as we go ahead. There are a lot many installations happening. And you will not believe all the OEMs, those who are manufacturing of the wind turbines, they all are trying to educate our policymakers. Somebody says it is a lobbying, but I say education, because these politicians, they need to understand what this industry is facing as a challenge. And then they need to start working around the policies supporting this industry, because if this industry does not survive and more installation doesn't happen, then their target, this government are declaring their target into a COP26 or COP28. They are committing the targets and they will not be able to meet this target by themselves. They need the industry support. So long story short, or long answers is the short answer is yes, we need to keep on educating our politicians about policy formulation, and we need to find how best we can do. Another option is to avoid this constraint, go for the offshore machines. You don't have the land constraint, you don't have any permitting constraints. Still, offshore machines also takes the longer permitting challenge.
Okay, sir. Thank you.
Again, any question? Participants, please ask.
Good, we can conclude.
Yes.
Yes, sir. A heartfelt thank you to our resource person, Mr. Manish Hatwar, sir, for sharing your valuable knowledge on the topic renewable energy, an important need of today's era, offshore wind, enabling global energy decarbonization. Your presentation was really engaging and informative, sir. I also thank all the participants. Thank you, sir.